In this paper, we propose transporters with visual foresight, a novel method for task planning from image data which is able to efficiently learn from only a handful of training data. Given a handful of expert demonstrations on multiple tasks, our first goal is to achieve multitask learning, which learns these tasks and generalizes to unseen poses. Our second goal is to achieve zero-shot generalization to unseen tasks which are not present in the training data. We first introduce the visual foresight model, which predicts next step observation based on the current scene and a pick-and-place action. Secondly, we develop a multimodal action proposal module, which builds on a state-of-the-art imitation learning method called the gold condition transporter networks. Combining the visual foresight model and the action proposal with the tree search algorithm, we propose transporters with visual foresight, a method for task planning. The visual foresight model takes as input the current observation and a pick-and-place action. We encode the picking action as a binary image, which is positive within a square area at a picking position. To encode a placing action, we first rotate a current observation by the placing angle. Then crop the rotated observation and paste the crop at a placing position to make the placing image. The action images and the current observation are then concatenated together and sent into a fully convolutional network, which outputs the next step observation. By encoding the action in the image space, our method naturally inherits the translational equivariance feature of fully convolutional networks. When applying a translation on the current observation and the action, the next step observation will concurrently be transformed by the same translation. It allows our visual foresight model to learn efficiently and predict accurate next step observations with only tens of training data. To propose multiple actions, we first use the goal condition transporter network to obtain a picking position and a placing action value map. Each channel in the map represents a placing rotation angle. Each pixel represents a placing position. We first apply a channel-wise maximization to get a best rotation for each pixel. K-means clustering is used to group the placing positions into clusters. Within each cluster, we select the placing position with the highest value and its corresponding best rotation as the proposed placing action for the cluster. Each placing action is paired with the picking action to form a pick and place action. Transporters with visual foresight takes as input the current observation and a goal observation. The action proposal module generates multiple actions based on the current observation. The visual foresight model predicts the next step observation for each action. We repeat these two steps until the tree reaches the maximum depth. The predicted next step observations in all layers of the tree are collected and compared to the goal observation. Finally, the robot takes the first action leading to the observation closest to the goal in a model predictive control fashion. After taking the action, the robot replans again for the next step until the maximum step number for the task is reached. We trained the model on 6 training tasks with 10 demos per task. Here we show testing results on 2 training tasks. Here we show the testing results on unseen tasks which are not present in the training data. We also test our method on a real robot platform. We trained the model on 3 training tasks with 10 demos per task. Here we show the testing results on 3 training tasks. Here we show the testing results on 3 unseen tasks which are not present in the training data. The failure cases of our method are mainly caused by inaccurate placing actions and incorrect action proposals. Please see the paper for more details. Thanks for watching.